This short video will focus on the technical model of a running drill, the sled pull. Along with describing the technical model, we'll also discuss how the level of resistance, so how much weight is put onto the sled, can determine the effectiveness of the drill. Traditionally, the sled pull has been a strongman exercise, but in recent years, it's been popularized largely by the commercial fitness scene, such as CrossFit, but it's also made its way into the S.N.C. coach's toolkit. There are a number of ways to pull a sled, but one of the best is to utilize it in a way that mimics sprinting. As you can see here, the athlete is attached to a harness which is linked to the sled. The athlete is then free to sprint as normal without any interference with technique other than the weight of the sled. When pulling the sled via handheld straps, the athlete cannot use their arms to help power themselves through the running action and may hinder any beneficial crossover effects when they move to unresisted sprint training. A primary goal of sled pulling is to improve acceleration and sprint times over a short distance. When accelerating, so here let's think about accelerating from the blocks at a dead stop. We are looking for a low horizontal push-off with the athlete keeping their body in a strong forwards lean. What we don't want to see is the athlete moving into an upright position from the start too early. In this footage, we can see the athlete move into an upright position very early, which limits his ability to generate horizontal propulsion forces in the drive phase. Also seen here, the athlete hasn't achieved an explosive concentric full triple extension action, which will put restrictions on how much force can be generated. When using a sled for sprint training, the slight counterbalancing action of the external load behind the athlete allows for a more horizontal push-off. A more horizontal position allows for greater anterior-posterior propulsion forces to be applied than compared to a more upright position. If an athlete can learn and is able to explode out from the blocks in a more horizontal position, it's likely that their acceleration and therefore sprint times will improve. When performing a sled pull, it's important to focus on driving the knees up, pumping the arms forwards in a linear fashion, and trying to maintain a 45-degree angle forward lean, all while achieving explosive triple extension with each stride. Now, when determining how much weight to put onto the sled, often it's recommended that sled weight should be of quite a light resistance because it's believed that when the load is too heavy, running mechanics are disrupted, and this would lead to decreased sprint performance. However, a number of studies concerning this topic actually show that in some situations, heavier sled pulls are more effective. A study by Kawamori et al. Actually showed that in a 5-meter sprint test, only the group who performed heavy sled pulls showed an improvement in performance compared to those with a lighter load when they were training. Obviously, I've picked this one result from the whole study, but it is worth having a read to understand just how this heavier external load can be of use on a sled compared to a lighter load. Woodward et al. Also discuss how heavy sled pulling can be beneficial to athletes looking to improve their sprint times. Obviously, there are a number of other studies concerning this topic that could be of use to read, but these are just two that stood out for me.